Alright, today we're going to look at composition of functions, and today we're going to be looking at composition of functions whenever we're dealing with numbers that are put into these functions. So the first thing that we need to do is we need to do a little bit of review and look at finding values of functions from a graph. So below we have this graph. It's telling us this is f of x, and it's asking us for these different values here. So we can see this is a piecewise function that we've got here, and the first thing it asks us for is f of -1. And so what you can think of whenever it's saying f of -1 is that this axis right here is our x-axis, this is our y, or our f of x axis. And so here, this is looking for f of x, the y value, whenever x equals -1. So on our x-axis, we can go right here where we see that we would have a value of -1, and then we're going to go up to the function right here, to this point. The coordinates of this point are -1, 5. So the y coordinate, whenever x equals -1, would be 5. So f of -1 would be 5. So whenever you're finding f of something, you're going to be reporting the y coordinate that goes there. The next question asks us for f of 6. So if we go to the x-axis, 6 is going to be right here. And if we go up to the function, we're talking about this point right here. The coordinates of this point right here are 6, 1. And so f of 6 equals 1. Remember, you're always reporting that y value whenever you're finding f of a value. Now, number 3 is a little bit trickier because it's going to ask us for f of -2. And if we go right here to -2, you can see we've got this big jump in the graph. And so what we're going to do whenever this happens is we need to use whichever part of this piecewise function has the colored in circle. So right down here we have the open circle. That is not what we're going to use. We're going to use the colored in circle, which is right here. So we're looking at this point on the graph, and the coordinates of that point are -2, +4. So the y coordinate there would be +4. So our answer for number 3 would be +4. Now, all of these we were given the x value. We're finding f of an x value. But sometimes they'll ask us to find the x that goes with certain y's. So for example, here it says, if f of c equals -3, find the value of c. So f of c, we can think of this as like our y value. If y equals -3, we want to know the value of that c. That c right there is our x value that we're looking for. So if I look on the y-axis this time, the y-axis at -3, I'm going to look for any points where y is -3. And in this case, there's only one, but we'll see on the next problem, sometimes there can be 2 points where this happens, or 3 or 4. And we can see here the coordinates of this point are -3, -3. And so the x coordinate that goes with this would be -3. So that c value right here would be -3. Maybe not the best example since those numbers are exactly the same, but we're looking at that x right there. Is where we get that -3. For the last example that goes with this graph, it asks us to find the value of x, or find the x value or values for which f of x equals 4. So we're looking for where our y coordinate equals 4, which is going to happen right here. And so we've got 2 points where our y coordinate is 4. We've got this point right here, and we also have this point right here. So we've got the coordinates of this point. They are -2, 4. We already saw that earlier. And then right here we have the points of the coordinates 0, 4. So for this, you're actually going to have 2 answers. you're going to have that negative 2 and x equals 0. So you're reporting those x values that go with this. So it'll be really important that we're able to do this in order to do the types of questions that you will see on the composition of functions assignment that you will have. So let's start to look at composition of functions. So that word composition means that you're putting two things together. You're composing that together. A composer of music puts together a bunch of different notes, and then it sounds like a beautiful piece. So composition means to put together. So whenever we see composition of functions, one way that it can be written is like this right here. And we read this as f of g of negative 6. And so what's most important to remember is that you need to start from the inside and work your way out. So whatever's on the inside, that's what you're going to look for first. So on the inside here, we have g of negative 6. And so we're given these graphs right here. We have f on the left and g on the right. And we're going to look at g of negative 6. So negative 6 is right here on the x-axis. If we find that point where we have that x-coordinate of negative 6, the coordinates of that point right there are negative 6, negative 2. So that tells us that g of negative 6 is negative 2. So we can replace g of negative 6 with negative 2. That means we'll be finding f of negative 2. And so if we're looking for f of negative 2, now we're looking at the other graph. So we can see right here, our x-axis, we have negative 2 right here. And our point on the graph right there for negative 2 is right here. The coordinates of that point are negative 2, 4. So the y-coordinate that goes with x equals 2 on the graph of f is 4. So our answer for this would be 4. Okay, let's try another one. Okay, similar question here. We have two graphs, f and g. However, notice this time that the g is on the outside and the f is on the inside. We always want to find whatever is on the inside first. So we need to find f of 3 first. And so we're going to use the graph of f, and right here on our x-axis is 3. If we look at this point right here, the coordinates of that point are 3, negative 3. So our f of 3 equals negative 3. That means now we've got g of negative 3. And now g of negative 3, we have to use our graph of g, and negative 3 right here is right here on our x-axis. We are going to use the coordinates of the point right here, which are, in this case, negative 3, negative 3. And so our answer for this is going to be negative 3. Okay, so this is what we do whenever we have graphs. Sometimes we don't have graphs. Sometimes we have just equations. Okay, so here we're given two functions, f and g, and we're asked to find g of f of negative 2. So we have to find the inside part first. So we're going to begin by finding f of negative 2, which means we're just going to plug into negative 2 in for x into that f function. So we're going to have 5 times negative 2 plus 4, and that is going to give us negative 10 plus 4, so that's going to be negative 6. So now we have to find g of negative 6. And so we're going to plug that into our equation here. We'll have negative 6 squared minus 6 times 6 minus 13. And we are just going to evaluate that. So negative 6 squared is going to be positive 36. Negative 6 times 6 is going to be negative 36, and then minus 13. Here, of course, these 36s are going to cancel, so we're going to get that g of negative 6 just equals negative 13. So that would be our answer for this problem. Okay. Okay, on this next problem, we have a similar setup, but we do have notation that is a little bit different right here. And just depending on, what kind of textbook or program you're using, sometimes this notation right here will be used for g of f of 5 rather than the other notation that we have seen before. I like the other notation better, but some textbooks and programs use this notation, so I want you to be familiar with it as well. When you see g of f of 5 right here, this is the same as g of f of 5, like this. So whichever one is closest, that is your inside function. So the first thing we would need to do here is find f of 5. So we're going to plug 5 into our f function. So we'd have 5 squared minus 5 times 5 minus 7. So we've got 25 minus 25 minus 7. I promise this doesn't always happen. It's just got these problems from Delta Math. They're probably similar, I guess. So that gives us negative 7. And then we need to find g of negative 7. And so that will be negative 3 times negative 7 minus 6. That's positive 21 minus 6, which is going to give us 15 as our final answer there. Right. Let's look at just a couple more examples here, and this time we're going to see sort of this mix together where we have both a graph and an equation. So if we look at example 10, it asks us to find g of f of 2. And so the graph gives us f, so this right here is f of x, and g of x is our function 2x plus 5 over x. So the first thing we need to do on this is we need to find f of 2. And so this also gave you one where it's a little bit tricky because right here at 2, you've got two different points, but you're going to use the one that's colored in. So the coordinates of that point right there are 2, negative 3. And so that means we're finding g of negative 3. And so we're going to plug in negative 3 into that equation. 2 times negative 3 plus 5 all over negative 3. And that is going to give us negative 6 plus 5 over negative 3, which is negative 1 over negative 3, and so we will get positive 1/3 for that answer there. Now, 11 is a little bit strange. 11 asks us for f of 5. And so f of 5, we're going to do just like we've done the other problems, except for we're only using f this time. So we have to start in the middle right here. In the inside, and we're finding f of 5, and so f of 5 right here is where our x-coordinate is 5 at this point. The coordinates of that point are 5, 0. So that means that f of 5 is 0. So we have now f of 0 that we need to find. And so f of 0, we're still looking at the same graph because we're finding f of 0. And 0 is right here on our x-axis. The point that goes with that on the graph here is right here. And the coordinates of that point are 0, 1. So the y-coordinate that goes with this here is 1. So 1 would be our answer here. So you will have an assignment in Delta Math that you will do that will do some of these problems here. So please complete that. And if you have any questions, let me know.